Good evening, one and all. In this previous class, we have discussed about analysis and design of synchronous clocked sequential circuits. So mainly we have discussed about how many type of synchronous sequential circuits. Sequential circuits are mainly two different types. One is like Murray circuit and the Miller circuit. Miller circuit. And what is the difference between Murray circuit and Miller circuit? We have discussed with the help of block diagram. The Murray circuit output depends only on the present state. Okay, in the Murray circuit, output depends upon only on the present state of the flip flop. Present state of the flip flop. But Miller circuit output depends upon present state of the flip flop as well as the input Okay, so we have also discussed about Murray circuit block diagram. We have seen that how is it actually. This is my next state decoder. Next, it has memory element and the output decoder, and these are my inputs, and few inputs will be feedback from. Okay, so this is the way we have discussed. Understand, this is called Murray circuit. In the Murray circuit, outputs of the circuit depends only on the present state of the flip flop. Okay, only on the present state of the flip flop. But in case of Miller circuit, so how is it actually? This is my next state decoder. So please see the difference. This is my next state decoder, and these are my memory element. It goes to memory element. And finally it will go to, and few of them will get feedback, and finally this will go to output decoder. And you can see here few of them will depends upon the input also. Okay, that's why what we can say here, the output of the Miller circuit, this is my Miller circuit, depends not only on the present state but also on the inputs. Okay, these are my inputs, you can say, but also on the inputs. Okay, do you all understand? And for another thing, input changes doesn't affect on the output for the Murray circuit, but in Miller circuit, input changes will affect because input is directly connected to the output of the decoder. So if input changes, then output is also going to change. Okay, so this is my Miller circuit. And next thing is, it requires more number of states for implementing function. In case of Murray circuit, the number of states required to implement the function is more compared to the Miller circuit. Okay, these are the differences between Miller circuit and Murray circuit. And so we have also discussed how to design the synchronous clocked sequential circuits. Like, there are different steps we have discussed. Step one would be, first, from the given state table, okay, from the given state diagram or from the given informations, you have to first obtain the state table. Okay, we will see one of the example also today. We have already discussed this. Okay, step one is obtain the state table from the state diagram or from the given information. Next, step two, reduce the number of states if possible, by using state reduction technique. Okay, next, step three is, we have also seen this. What is step three? My step three is assign binary values to each step. So my step three is assign binary values to each step. Step three is assign binary values to each step. Assign binary values to each state. Okay, step 1 we have already seen, obtain state table, obtain state table. Next, step 2, reduction of states, if possible, reduction of states. Next, assigns binary values to each state. Okay, there are mainly, let's say, 5 states like A, B, C, D, E. So in order to represent these 5 states, we need how 5 can be represented using 1, 0, 1. So we have to represent this. A will be 0, 0, 0, B will be 0, 0, 1, C will be 0, 1, 0, D will be 0, 1, 1. Next, 1, 0, 0. Like this, we have to assign those. Okay, those steps. 0, 1, 1, 1, 0, 0. Okay, these are the 5 states you have to assign. Let's say it has 4 states A, B, C, D. So you can assign 0, 0, B will be 0, 1, C will be 1, 0, D will be 1, 1. Because for 4 states we require 2 square, so it is 4 number of states. So obviously we need 2 bits to represent those states of binary. So that's why we require A, B, C, D to represent binary values are 0, 0, 0, 1, 1, 0, 1, 1. Okay. Next, step 4. What is step 4? The step 4 would be determine the number of flip-flop needed. Determine the number of flip-flop required and the type of the flip-flop. And the type of the flip-flop to be used. Okay, to be used. So with the help of this formula, 2n is greater than equal to n. So here what is n? N is the number of flip-flops and this is number of states, and here n is number of flip-flops. So with the help of this particular formula, you need to find out how many number of flip-flop required to design that particular state diagram, okay, to the particular sequential clocked sequential circuit. And so let's say it has 4 number of states, let's say A, B, C, D. So how many flip-flop required? 4 states means 2 to the power 2 greater than equal to 4. So obviously how many flip-flop? 2 flip-flops required. 2 flip-flops required to design that particular sequential circuit. Okay, all of you understand. Next, what is step 5? Step 5 is from the state table derive the circuit excitation table and output table. Okay, so what is step 5? Step 5 is from the state table derive the circuit excitation table and output table. Okay, this you can find out. I'll tell you how. And what is step 6? Step 6 is using K-map derive the output function. Using K-map derive the output function and flip-flop input functions. Using K-map you have to derive this. I'll tell you. Next, step 7 is draw the logic diagram, draw the sequential circuit, or sequential circuit. Okay, so these are the various steps to design the sequential circuit or clocked synchronous circuit. Okay, like we have also seen that how to design the combinational logic circuits, we have to follow 6 different steps. Like we have to first understand the problem statement. Next, for combinational logic circuit design, how? First you have to understand the problem statement. Next, you have to derive the number of inputs and output required to that problem statement to solve. Next, you have to assign the letters to those inputs and outputs. Next, fourth step is you have to construct the truth table depending upon the behavior of the circuit. Next, you have to find out the output functions by using K-map, by minimizing techniques of K-map. Next, at the end, you have to implement. Similarly, in order to design the sequential circuits, you have to follow few steps. First, you have to obtain the steps table from the state diagram or the informations given, then reduce the number of states, because if the number of states more, then number of flip-flop required is more. You have seen this equation, you have seen this particular formula. Okay, if number of states are more, obviously the number of flip-flop required to design it sequential circuit is more. That's why it should be cost high. That is the reason we have to reduce the number of states if possible by using state reduction technique. I will tell that. Step 3, assign the binary values to each states. If there is 4 states A, B, C, D, you can assign with 4 states means 2 square, 2 number of binary values required 0, 0, 0, 1, 1, 0, 1, 1. You can assign it like this. Okay. Next, step 4, determine the number of flip-flop required and type of the flip-flop to be used using this particular formula. 2 to the n is greater than equal to n. Next, step 5, from the state table derive the circuit excitation table and output table. I'll explain more about it, don't worry. Next, step 6 is using KMF derive the output function and flip-flop input function. Okay. Then finally, after that, step 7, draw the logic diagram to get the final sequential circuit. Okay, understand? Any doubt on this? If not, we'll go for next. So we'll do one of the questions so that you can have better idea about it. In the last class, we have discussed about one Millet circuit. Now we'll do one Murray circuit. So what is the question? How the question will come in exam? Some of the like circuits will be given for you. You have to find out the either the state diagram, or from the state diagram some of the circuits has been given. You have to map to that particular state diagram. So you see here, what will be the question? The question will be here, realize the sequential circuit. Just see here, very important question. Sequential circuit for the state diagram given. For the state diagram given. So let's say the state diagram is here, A 0, just see here how the state diagram. I'll explain this also, don't worry. Okay, so this is the state diagram given. Okay, so obviously by looking into this, what you can understand, this is what type of circuit actually you have to design. You have to design a Murray circuit. In the case of Murray circuit, the state diagrams are like this. So here, what are the states? The states are A, B, C are the 3 states. Okay, okay. Now what is happening here? This x is equal to 0 and x equal to 1. These are the transition during, sorry, inputs. These are the inputs, and this is my output. This is output. This is state, and these are the inputs. Okay, like this way, this is the thing. So this is actually Murray circuit. You can say Murray circuit. In Murray circuit, output of the circuit depends upon the present state only. Okay, so from this is the state diagram given to you. From this state diagram, what is the first step? The first step is you need to obtain the state table. Okay, you need to obtain the state table. Okay, do you understand? First, in the step 1, you need to obtain the state table from that particular state diagram. Okay, so what you need to do, you have to first find out the state table, obtain the state table from the given information or from the given state diagram. So what is the state table? Actually, the state table consisting of the present state. Okay, so tell me here, what would be my present states are? Present states are mainly, how many states are here? A, B, C are my states. So my present state would be like A, B, and C. Okay, and next state, the state table consists of next state, and the next state, just see here, if input is 0, x is 0, it is going to another state. And input is 0, you can see it is going to the next state C, and input is 1, it is going to the next state A. Okay, are you understanding? So there are 2 possible states. It is going from the present state to the next state depending upon the input. Okay, so here you see x is equal to 0 and x equal to 1. What do you understand from this? What I have discussed now. Okay, the particular at x equal to 0, it is staying in this own state, and x equal to 1, C is now present state is C, it is going to A. Okay, so that's why there is 2 possibilities for the next state over here. Next to it will be output. Output will be always Y. Okay, so output will be always Y. So this is my state table. I'm going to fill up this. How? Now just see here. Okay, you have to obtain this state table from the given state diagram or from the given informations. But here information is not given, just it is given like a state diagram. From that you have to derive it up. Just see here. Now I am at the present state A. Now I am going to B when input is 0 as well as input is 1. So what will be my next state? Next state would be B for input is 0 as well as B for input is 1. Okay, do you all understand here? Next, what will be my output? For both the cases, what will be my output? Output will be 0. Sorry, output will be 0. For this A, what is my output? Output is 0. Okay. Now, for B, now present state is B. Now at x equal to 0, so this is only x equal to 0, x equal to 1. So at x equal to 0, I am going to where? Next state C. As well as for x equal to 1, I am going to where? C only. So what will be my B? Next state will be C and C. What is my output at that time? My output is 0 only. Okay. So my output is 0. Now I am at present state C. So if my input is 0, I am going to be present in that same state, that is C. And now if x equal to 1, input is 1, I am going to next state A. Am I correct? I am going to next state A. And what will be my output? My output is obviously here. My output is 1. Okay. So I am going to write down my output is 1. Okay. So do you all understand? This is the state table. Okay. From the given information or the state diagram, I have derived my state table. Okay. Now, what is my step 2? My step 2 is any state reduction possible or not. So how to identify any state reduction? Using state reduction technique. So what is state reduction technique? Is there any possibility that two states, two present state, okay, two present state having same next state and output? Just see here. Is there anything possibility this present state has next state B, B and 0. This present state has next state C, C and 0. This present state has next state C and 1. So if see here, if anything is possible here, no. Why? There is no possibility of state reduction since no two states, next state and outputs are same. Okay, so no state reduction is possible. Why? Just see here, if there is C0, then it's possible. Okay, you can remove one state. Okay, because here all the states next state is different and output is also different. That's why I will be not having any state reduction. No state reduction. Okay, because no two states means out, if these two states, these values are equal, then only we can have one state. We have to reduce it. One B will be removed. Okay, so that's why though no state reduction possible. Next, step 3. What is step 3? You have to assign the binary values to the states. Okay, assign the binary values to the states. Okay. Okay, so what are the states here? Mainly there are 3 states, A, B, C. So in order to represent these 3 states, how many number of binary term required? Just 2 terms, because in order to represent 2 square, we have 4 different states we can represent. So we have only 3. That for that we can have easily, we can represent this 0, 0, B will be 0, 1, C will be 1, 0. Understand? So this is the way you can assign the binary values. In some questions, what they will do, instead of that, they will just given here 0, 0, 0, 1, 1, 1, 0. So at that time also, this step is not required. Already you have assigned the binary values in the state diagram, so no need to assign the binary values again. Okay, in the previous class we have seen here that we no need to actually require any binary values to assign, because already the states are in the binary values. Okay, but here the states are in A, B, C, so we have to represent that in the binary values. Okay, do you all understand? Next, step 4. What is step 4? My step 4 is you have to identify, determine the number of flip-flop required and type of the flip-flop. You have to decide, and type of flip-flop. Okay, so for that case, what you need to do, you would have one formula, 2 to the n greater than equal to n. So obviously here it is given 2 to the n greater than equal to 3. So n is number of flip-flop. Okay, number of flip-flop, and this n is number of states. So here how many states? Obviously 3 states. 2 to the n greater than 3. So what would be my n? My n will be obviously 2. Am I correct? Understand? So obviously now number of flip-flop required is 2. Flip-flop required is 2. Now let's say here in the question it's not given. Let's say in the question given, realize the sequential circuit using D flip-flop for the given state diagram. So the flip-flop is already defined, but here the flip-flop is not defined. It has been asked you only to realize the sequential circuit. So you can take any type of flip-flop. Let's say the type of the flip-flop I am taking here, T flip-flop. Type of the flip-flop to design this sequential circuit is a T flip-flop, let's say. Okay. So now what I have to do? Next, step 5. What is my step 5? I have to obtain the excitation table of the given circuit. Okay. Excitation table. You have to obtain the excitation table. So how we can see here now? Before that, you should know what is the excitation table of the T flip-flop. What is the excitation table of the T flip-flop? We know that what is excitation table? It is the relationship between present state, next state with the flip-flop input. So this will be my excitation table. Am I correct? So there are how many present state? 0, 0, 0, 1, 1, 0 and 1, 1. What would be my T? T will be, what is T? What is the T? Qn plus 1. If the next state will be always Qn. If T is 0, if T is equal to 1, Qn plus 1 is Qn bar. Okay. So if T is 0, then this is 1, 1, 0. Okay. Do you all understand? So this is my excitation table of the T flip-flop. Okay. So in order to identify, in order to convert the one flip-flop to another flip-flop, you would have required few things. Actually, you need to know the excitation table, and also in order to design a sequential circuit, you have to study this excitation tables. Excitation tables are very important, students. You have to remember these excitation tables. Okay. So next, what way you need to find out the excitation table of the circuit? So excitation table of the circuit consisting of the present state. Okay. Next, input will be what? X, and present state will be what? Let's say how many flip-flops here? 2 flip-flops. 2 flip-flops means QA, QB. Okay. Next state. Next state means what? QA plus 1, QB plus 1. Okay. Next, flip-flop inputs. Flip-flop inputs. What is my flip-flop inputs? There are 2 flip-flops required, TA, TB are flip-flop inputs. Finally, output of the circuit. Output of the circuit, which is Y. Okay. Y. Understand? So this will be there in the excitation table. How we can find out? Just check here. This is my excitation table. Just see here, QA, QB and X, QA plus 1, next state, flip-flop inputs, TA, TB. So my present state is what? Just see here in this present state, A. A means it's actually what would be my states actually? So these are actually A. A means 0, 0, 0, 1, 1, 0. So this is QA, QB. Am I correct? So this is my 0, 0. Okay. For that time, for X equal 0, it has one next state. For X equal to 1 also, it has one next state. So for 0, 0 state, X equal to 0, one next state. And for 0, 0 present state, X equal to 1, another next state. So how is it? What is my next state? If it is state is 0, 0, what is my next state? B for X equal to 0. B means what? B means obviously 0, 1. Okay. And next, at X equal to 0, what is my next state? Again B only. So 0, 1. Understand how I am doing? Very simple. Next, how to find out TA, TB? We know the present state and next state. Present state is 0, next state is 0. What is my T? T is 0. Present state is 0, next state is 1. What is my T? T is 1. Okay. And what is my output Y? Output Y is for X equal to 0 or X equal to 1, whatever may be the case of this, for this present state, the output is 0. So I am going to write down output is 0 for both the cases. Do you all understand this? How I have got actually? Any doubt on this? Now, let's say we have 0, 1, 0, 1, So input is 0, input is x, 1. So what will be my next state? For B, my next state for x equal 0, input is 0, my next state is C. C is what? 1, 0. C means what? We have already assigned C means 1, 0. That I am going to put over here. C, 1, 0. Okay. For x equal to 1, what is my next state? C only. C means again it is 1, 0. Now tell me what is my TATB? My TATB is for present state 0, next state 1, my TA is 1. And similarly here also you have to find out 0, 1. For 0, 1, it is 1. Okay. Similarly 1, 0, 1, present state is 1, next state is 0. What is my TA? Is 1. TB is 1. Present state is 0, next state is 1. What is my TA? 1. Present state is 1, next state is 0. What is my TB? 1. Okay. Do you all understand? Now what is my output? My output is always 0. If it is x is 0 or x is 1, my output is 0 for the state B. Okay, very simple. Next is 1, 0. If my state is at C, present state is at C, that is called 1, 0. So input is 0, input is 1. At that particular time, what will be my next state? Just see here. For inputs, present state is 1, 0. At that time, next state is C, means it's at 1, 0. Okay. And for 1, x equal to 1, it has A. A means 0, 0. Okay. A means 0, 0. Okay. Now what will be my TATB? 1, 1, TA is 0, 0, 0, TA is 0. Present state is 1, next state is 0, TA is 1. Present state is 0, next state is 0, TB is 1, 0. Okay. And what is my output? My output is at present at for the present state C, my output is always 1, whatever may be my inputs. Okay. Whatever may be my inputs, it is 1. Okay. So this is my excitation table. Do you all understand, students, how I have drawn the excitation table? From the state diagram only I have drawn. Any doubt, please let me know immediately. So after that, what is my step 6? This is my step 5. Now step 6 is you need to simplify the flip-flop inputs and the circuit output. Okay. Simplify the flip-flop inputs and circuit output. So what is my inputs here? TA, TB is my inputs. TA, TB. So you have to simplify for TA, you have to simplify for TB, you have to simplify for output circuit Y. Do you all understand? So what you need to do for simplify TA, what would be my TA? You have to do KMF simplification. So obviously what are my inputs? My inputs are QB, QB and X. So we require 3 inputs, so it's required 3 variable KMF. So how we have to draw 3 variable KMF? Very simple. So where QA, QB, X. So it requires 8 cells. So I have just drawn the 8 cells. So these are my QB bar, X bar, QB bar, X, QBX, QBX bar, and this is my QA bar, QA. Okay. And we know the minterm positions 0, 1, 2, 3, 4, 5, 6, 7. Okay. So next, what are the minterm for this TA? What are the values? 0, 1. So this is my minterm 0, minterm 1, minterm 2, minterm 3, minterm 4, minterm 5. And what about other minterms 6 and 7? Because it has 8 minterms. So obviously minterm 6 and minterm 7 are don't cares. Okay, because in this table there is no more states to represent. That's why minterm 6 and 7 are don't cares. Very important, students. Okay, so obviously minterm 6 and 7 are don't cares for every time. Okay, and where the minterms are present? Minterm 1 is present, 2, 3, 5. 1, 2, 3, 5. 1, 2, 3, 5. Other places 0. Okay. Do you all understand what you need to do? Now you know that how to group it. Very simple. You need to group one quad, and sorry, this 2 is not there. This 2 is present. TA. So see here 0, 0. 0, 0 means it's 0. Okay. So this is 0. Okay. So this will be my 0. So obviously how to draw this? Next, this is the grouping. So what would be my common here? My common would be here. This is common over here, QB, and here this one is QAX. Okay, any doubt? So we got TA, which is QB or QAX. Okay, any doubt on this? So like this we can find out TB also. TB also is of 3 variable KMF. We just require 3 variable KMF for TB as well. So we just find out that as well here. So TB, another input function. So TB will be flip-flop input. So it actually require again 3 variable KMF which has 8 cells. So this is also QA, QBX, QB bar X bar, QB bar X, QBX, QBX bar. Okay, this is QA bar, QA. And we know the min-term positions 0, 1, 2, 3, 4, 5, 6, 7. Okay, so now tell me what are the TB positions are there? TB where it will be M0, M1, M2, M3, M0, M1, M2, M3, M0, M1, M2, M3, and these two are don't cares and these are zeros. How to combine these, students? Very simple. We just need to combine it this quad. Anything else? No. Okay. So what is common here? QA bar. So what is TB? We got TB as QA bar. Okay. Any doubt on this? Next, output of the circuit. Output of the circuit is Y. Again, it's a 3 variable KMF required to design or simplify it. What is the output of Y? This is the output function. So we can have this Y. It also again a 3 variable KMF. So we have to construct a 3 variable KMF which has 8 cells. So these are my 8 cells. So this is again QA, QBX, QB bar X bar, QB bar X, QBX, QBX bar. This is my QA bar QA. Okay, and we know the min-term positions. These are 0, 1, 2, 3, 4, 5, 6, and 7. And we know that what are the min-terms present for T, like M4 and M5, M4 and M5, and these are don't cares, and other places just 0. Okay, so how to combine it? Very simple. We can have combine this. This is the way we can combine it. Just only one quad. So this is my combinations. What is common here? QA. So Y will be mine QA. Any doubt on this? So finally what we have to do? We have to design the sequential circuit now. That is my step 7. My step 7 is we have to draw the sequential circuit. So we would have how many flip-flops here? We require how many flip-flops? We require 2 flip-flops. So mainly it has 2 T flip-flops. Mainly it has 2 T flip-flops. One is this is T and this is my QA bar. Okay, and this is my TA. Next it has another flip-flop TB and it has QB bar, and this is actually what clocked sequential circuit. Okay, clocked synchronous sequential circuit. So clock will be common like this. So clock will be common clock, synchronous clock. Do you all understand? Same clock will be applied to any of the flip-flop required to design. Now tell me what are the functions we have achieved. TA is what? TA is QA x QB. So where is my QA? So this is my QA. Okay, and X, QA X and QB. Where is my QB? This is my QB. I can take like this QB, and this is my QB. I have taken a OR gate and which will be connected to TA. Okay, any doubt on this, students? Very simple. So finally my design would be, so this is my OR gate, and finally my design will be like this for TA. And now this is my X, input X. Okay, and what is my TB? My TB is QA bar. QA bar means just simply I can put a NOT gate here and connect over here, which will become TB. Okay, my QA bar, my TB is what? QA bar. You can see QA bar. So I can do it like this. And what is Y? Y is nothing else, my QA. So what is Y? Y is nothing else, my QA. So how can I take that Y? So this is my QA. I can take it from here and just a jumper and tell that this is my output Y. Okay. So finally we have designed this sequential circuit of the given state diagram. So this will be nothing else. This is nothing else, my designed clocked sequential circuit for the given state diagram. Okay. All of you understand, or any doubt, students, please let me know. So this is the way you can design your sequential circuits. First you have to obtain the state diagram. Okay, we have done here state table. Next, state reduction technique to reduce the number of states. Then assign the binary values to the state. Then find out the number of flip-flops and type of the flip-flop. If the type of the flip-flop is given, use that particular flip-flop. If not given, you can take anything, any of the flip-flop your wish. Okay. Next, excitation table. With the help of excitation table and the state table, you can find out the excitation table. From this, you can find out the flip-flop inputs and your output of the circuit. Then finally, you can simplify the flip-flop inputs and output of the circuit using K-maps and simply draw the sequential circuit. These are the analysis and design of the sequential circuit, which is clocked sequential circuits. Okay, clocked synchronous sequential circuit. Okay, why is it synchronous? Because clock is given, same clock is given at a time to both the flip-flops. Okay, this is my T flip-flop A, this is my T flip-flop B. Any doubt on this? Please let me know, students. Very simple. We'll do only one more problem, okay, so that you can have better idea about it. After that, next part we'll see. So let's say another problem is, let's say it is given. Next question. Any doubt? Anybody has come up with any doubt? Okay, good, no doubt. So we can have do one more last question on this, because this is very important. One of the question you can expect actually. Design a clocked sequential circuit for the state diagram given. Okay, what will be my state diagram here? A, just see here how the state diagram I'm doing. B, C, D, E. Okay, so this will be my state diagram. Just check here, A to B, 0 by 0. Next, D to A, 0 by 0. B to D, 0 by 1. Next, D to E to D, 1 by 1. E to C, 0 by 0. Next, this is 1 by 1, 0 by 1. Okay, and A to C, it has 1 by 0, 0 by 0. Okay, any more states are there? Yes, one more state is from here, B to E, 1 by 0. Okay, so these are the state. This is my state diagram. First of all, what you need to do, you need to realize this clocked sequence circuit for the given state diagram. So this is little complicated, students. Okay, so what you need to do, how the easiest way you have to do in the GATE exam, I'll tell you at the end. Don't worry. Just see here how many states are there. A, B, C, D, E. So total 5 states are there. Okay, and this is what type of circuit? It's a Miller circuit. In Miller circuit, how we can be do the things. This is my state, and this is my input, and this is my output. Okay, this is my input and this is my output. So let's say I am at state A. Now at input 1 I am going to state C. At input 0 I am going to state B. At that both the time, what are my outputs? My outputs are 0 for input 1 and outputs are 0 for input is 0. Okay, this is the way you need to analyze this state diagram. Okay, next, what you need to do, first step, what you need to do, the first step is you need to obtain the state table from the given state diagram. Okay, we have been given here state diagram. We need to obtain the state table. In the state table, what would be there? Mainly it would be present state. Okay, next state. Okay, output Y. So tell me, present state would be what actually? What are the states are present here? A, B, C, D, E are my states. A, B, C, D, E are my states. Am I correct, students? Very simple. and the next state is obtaining. How the next state is obtaining here? How the next state is obtaining here? Just check here. The next state is obtained for input 1, one next state, for input 0, another next state. Okay, so it has for x equal to 0 as well as for x equal to 1, two different states they are obtaining going. Okay, similarly output also have output for x equal to 0, one output, and for x equal to 1, another output. Okay, for output also for x equal to 0, one output, for x equal to 1, another output. So for now you are in state A. So at input x equal to 0, which state you are going? Next state will be P. Okay, you are going to P. Next, if input is 1, where you are going? You are going to C. Am I correct? So you are going to C. Next, at both the time, what are my outputs? For x equal to 0, my output is 0. For x equal to 1, my output is 0. So both the cases, my outputs are 0 and 0. Okay. And now I am in the present state B. For input is 0, I am going to next state D. Am I correct? So I am going to next state D. And for input 1, I am going to next state E. Because this is my input 1, I am going to next state E. And both the times, what is my outputs? At input 0, my output is 1. At input 1, my output is 0. At input 0, my output is 1. At input 1, output is 0. Okay, do you all understand how I'm doing? Now at my present state C, I'm at my present state C. So now I am here at input 0, I am at the same state C only. So I am at the same state C. And for 1, I am going to next state D. Okay, next state D. And what is my inputs? Outputs. My outputs are 0 and 1. So 0 and 1. Understand? Now at my present state D, for input 0, I am at the same state D. Okay. For input 0, where I am actually, I am at D. For my input 0, so E, what is given? 1 by 1. Okay. Here I have done small mistake actually in the state diagram. This is 1 divided by 0. So both the inputs are 0, 0 I have given. So I am at this state now. At input 0, I am going to A. I'm going to A. And for input 1, I'm staying at the same state, that is D. Now at x equal 0, what is my output? My output is 0. At x equal to 1, my output is also 0. Okay. So both the outputs are 0, 0. Now I am at present state E. Okay. For input equal to 0, I am going to next state C. And x equal to 1. At x equal to 1, where I am going? At x equal to 1, I am going to next state D. Okay, I am going to next state D. And what are my outputs? For x equal to 0, input 0, I have output 0. And at x equal to 1, my output is 1, 0 and 1. Okay, do you all understand now? This is my state table. We have obtained it from the given state diagram. State table. Any doubt, please let me know. I'll just pause it for 1 minute. Please just check it. Any doubt, please let me know immediately. Okay. So we have obtained the state table. After that, what is my step 2? My step 2 would be reduction of the states. Is it possible to reduction of the state? How you have to check? Yes, this is possible. Just check here. I'm just doing here. Just check here. For this state and for this state, what is my next state? CD, and output is also 0, 1. Here also my next state is CD, output is also 0, 1. For state E, the same next state and same output. For C also same next state and same. So one of these states you can remove it. Okay, one of these states you can remove it. How? You have checked here, these two next state, for two states, this next state and outputs are similar. So that's why the state E will be reduced. State E will be removed. State E will be removed. So now what is my what is my reduced state table? You can draw the reduced state table now. What is my reduced state table? After removing this, we can have reduced state table, and we can know here, just check here, what is my reduced, and you can say what is E will be now exchanged with C, because C and E are same. So wherever E is present, just change it to C. Okay, do you all understand now what you need to do? Wherever E is present, because for the state C and for the state E, the next state and the output are similar. That's why one of the state will be get, you can remove C also, you can remove E also, your wish, but whatever you are removing, according to that you have change it. Okay, so this is my reduced state table will be again like this. So this will be my present state. This is very important question, students. Present state, and it has next state. Next, for x equal to 0, one state. For x equal to 1, it has another state. Next, for output also same, output which is y. For x equal to 0, one output. For x equal to 1, another output. So just see here the present state. What are those? A. Now what are, how many states are there? Only 4 states. So A, B, C and D. Only 4 states, because E get removed because of same next state and the output. Okay, that's why it get removed. Okay, so what are my next state? B, C, 0, 0. So I'll just copy that, nothing else. B, C, 0, 0. Next, for state B, D, C, 1, 0. D, C, 1, 0. Next, for C, C, D, 0, 1. C, D, 0, 1. Next, A, D, 0, 0. For D, state D, A, D, 0, 0. Okay, do you all understand why you have to remove this state? Because that two, for state C and E, that for both the states, the next state and outputs are similar. That's why we have removed the one state by assigning the removed state into C. Okay, so this is my final state, reduced state table. Now what you have to do is, what is step 3? Step 3 is you have to assign the binary values. That is also called state assignment. You can also tell state assignment. What is state assignment? There are how many values are there? A, B, C and D. You just assign it as 0, 0. B assign it as 0, 1. C assign it as 1, 0. D assign it as 1, 1. Okay, this is the way you can assign it. So this is called state assignment. Okay, then finally, what is step 4? My step 4 would be the number of flip-flop required, and the type of the flip-flop. So here, how many number of flip-flop? Obviously 4 states, 2 to the n greater than equal to n. So obviously 2 to the n greater than equal to n is 2. 4 states, 4. N is 4. Capital N is 4. And n will be how much? N is 2. Okay, so these are number of flip-flop. So number of flip-flop required is 2. And what is the type of the flip-flop? It is nothing has been given here. So easiest type you can take type of the flip-flop as D flip-flop. So why D flip-flop? Because we know that for the D flip-flop, Qn plus 1 is D. The excitation table will be little easier. That's why I have just taken D flip-flop. Your wish, you can take D, T, JK, SR, your wish. Whatever the flip-flop you have to take, accordingly you can design it, nothing else. Then finally what you need to do, you have to, step 5 would be, you have to find out the excitation table. Okay, the excitation table, you first know the excitation table of the D flip-flop. How is it? We know that Qn plus 1, and what is my D? So there are 4 possibles, 0, 1, 1, 0 and 1, 1. Whatever my Qn plus 1, the same will be D. Okay, that's why I have taken D flip-flop. It's easy for me to remember the D flip-flop excitation table. Then you have to draw the excitation table of the circuit. Excitation table of the sequential circuit. Excitation table of the circuit, given circuit. You have to draw, find out. Okay, for that you know that it has present state. So here how many flip-flops? Obviously flip-flops are how many flip-flops? 2 flip-flops, because we have already find out from the relationship 2 to the n greater than equal to n, which is 2 flip-flops. So what is my present state? Obviously QA and QB. 2 flip-flop outputs are present states. And input, obviously there is input X, which may be 0 and 1 for that particular present states. Okay, similarly it has next state. Next state will be what? Next state will be QA plus 1, QB plus 1. Okay, Next, flip-flop inputs. So flip-flop inputs are what? What are the inputs? DA and DB. There are two flip-flops, two D flip-flops. That's why two inputs DA, DB. Now output which is Y. For X equal to 0 and 1, we can have to find out output Y. Okay. Now tell me for state 0, 0, 0, 0 means state A. 0, 0. Okay. X is 0 and X is 1. What are my next states? My next states are what? For X equal, for state A, for input 0, I have state B. For input 1, I have state C. So I can write down here for input 0, I have state B, which is actually 0 and 1. Okay. And for input 1, it's C, 1, 0. Okay. And what is my DA? DA depends upon the next state. Okay. So you know that Qn plus 1 is D. So we know what is D, whatever Qn plus 1 is similar. So I just has to copy this, nothing else, 0, 1, 1, 0. Any doubt on this? No. So what is my outputs for state A? What is my output? For input 0, output is 0. For input 1, output is 0. So my outputs are 0, 0. Do you all understand for state A how I have find out the excitation table? Now state B. For state B, assigned it's a 0, 1, 0, 1, and for input 0, input 1. What are my states actually? For input 0, state is D, means 1, 1, C, 1, 0. Okay, D, 1, 1, C, 1, 0. Any doubt on this? Okay, next what will be my D? Same, you have to copy, simple. Okay, and what is my outputs? My outputs are 1 for input 0, 0 for input 1. Okay, so 1 and 0. Any doubt on this, students? Next is C. Okay, C is 1, 0, 1, 0. Okay, next what is my input? Input 0 and input 1. For that case, what is my next state? C for input 0, D for input 1. C means we can write down 1, 0, D means 1, 1. So what is my DA, DB? Same, you just have to copy. Okay, what is my outputs? My outputs are for input 0, output is 0. For input 1, output is 1. 0 and 1. Okay, next 1, 1. D. State D for input 0, state D for input 1. Okay, so what will be my next states? We are going to see now. For input 0, my next state is A. Input 1, my next state is D. A means 0, 0. D means 1, 1. Okay, so just has to copy this 0, 0, 1, 1. And what are my outputs? For input 0, my output is 0. For input 1, my output is 0. Okay, 0, 0. Do you all understand, students? Any doubt on this? Please let me know. Any doubt? So now finally what you need to do, this is my state excitation table. Do you all understand excitation table? Any doubt? Immediately? Any doubt? If there is no doubt, we'll go for it. Next one, any doubt has been come up? No, I think. Yeah, no doubt. Then we'll go. Finally, what is step 6? Step 6 is you have to simplify to get the input functions. Okay, which is nothing else, my DA, DB and output of the circuit Y. You have to use the KMF to find out. So you know that you can have only 3 variable KMS. I'm not doing. So you will get DA as, let's say I'm just writing, you do it yourself, QB, QA XOR QB or X, and DB you will get like this, QA X nor X, and finally Y you will get like this. By simplifying the 3 variable KMF, you will get all this. I'm just not doing this QBX because you have done many KMF simplifications in the class, QA, QB bar, X. So these are my 3 equations. Now easily you can design the digital circuit. You can easily design the logic design. Okay, design logic. Okay, any doubt on this, students? Very important. Okay, if there is no doubt, we'll just stop over here. Okay, do you all understand? In the next class, we'll just do the